In this video, we are going to look at data visualization based on time. So here we're going to look at time, and we're going to have two variables. And as we go down here, we're going to look at if you have time as one of the measurements, and you have ratio or interval data, then you're going to create a line graph. If you have time and you have a nominal variable, you'll create a stacked column chart. And if you have time and ordinal data, you're going to create a bump chart. So in this video, we are going to look at how to create a line graph, a stacked column chart, and a bump chart. In all of these, we have information over time, and what's different is whether you are looking at information over time with categories, with ranked data, Likert scale opinions, or if it is some kind of count or measurement. So let's take a look at how to do that in Python. So just a reminder that you can find this workbook at drstephpowers.github.io/BIA, and we're doing the workbook called Data Visualization. You will then need to find the Excel files, the bargain clean, bargain numeric, and CRM clean that you'll find when you click here. Copy those to your Google Drive and make sure you have imported those in order to run the code. So we are working here where it says line graph, and we have already imported in data frame 3, which is the CRM clean data set. In order to do a line graph, we're going to need to do matplotlib.pyplot as PLT for our graphing, and then we're importing numpy as NP in order to manipulate some of this data. So what we have here is we're looking at question 1, and question 1 asks about the salespeople. Who's the salespeople in our customer relationship management? And what we want to do is we want to compare our salespeople over time. In this particular data set, we have question 5 and question 8. And so let's just go back to our data set. And so here we have in question 5 the day and month that they contacted an individual. And question 8, we have the average talking speed in March. Okay. So if we go in here, what we can do is we can plot. So here we have our time measurement, and we have these salespeople are contacting lots of different customers. So the question is through the month of March, is the talking speed of our salespeople, is it consistent with everyone they talk to? Is it consistent as we move through the month? So what we're going to do is we're going to take data frame 3, which is the table for our customer relationship management system, and we are going to separate it into 3 tables. One table that is just information about Zhao, one table that is just information about Taylor, and one table that is just information about Garcia. So we're going to create this new table that is just where question 1 equals Garcia, question 1 equals Taylor, and question 1 equals Zhao. So we've created 3 tables here. In each of these tables, so if I just actually show one table here, DF3, and we're focused here on question 8, which is why we've labeled it that way, but we could call it something else, .head. Okay. So when you look at it, it's the full data set, it is not coded, and this is just where question 1 equals Zhao is the A version of the table. And the C version of the table you'll see is just Garcia. Okay, all right. So to plot a line chart here, what we're going to do, and this one's going to have multiple lines. So for each line, you're going to have a row when you're developing your chart. So you can see here we have 3 lines, one for Zhao, one for Taylor, one for Garcia. So our commands here to create the plot have 3 here. plt.plot. What goes on the x-axis? The x-axis here is question 5. Question 5 is the date. Date contacted in March, day and month. Okay, so when we do our graph here, you can see on the horizontal, those are dates in March. March 1st through March 29th. Then we have here what goes on the y-axis. if we're looking at question 8 was average talking speed. We're measuring the talking speed each day in March when that salesperson contacts someone. And we're going to do this with A, that was one person, B, that was another person, and C, that was another person. We can put in here this plot AXH line is it plots a horizontal line at a particular number. And so what we hear is that the best talking speed for salespeople is at 44 words per minute. That's the ideal. Too fast and you're going too fast for people, too slow and people get bored. So for engagement, the ideal is 44 words per minute. So we've decided to add to this graph this horizontal line. And you can see if I take away this horizontal line and run this, the graph looks exactly the same. It just doesn't have that black line in it. So we're putting it in there because there is this ideal amount that we subscribe to. It is happening at 44. The color is black and we're making it a solid line here. So you can change the line style, you can change the color. And then what we're going to do is plot the legend. This legend, the order you put this in needs to match the order that you told it to plot. So A, we said was Zhao, and B was Taylor, and C was Garcia. We entered this in as A, B, and C. So first Zhao, then Taylor, then Garcia. So the first row has to match the first label. The second row has to match the second label. The third row has to match the third label. Zhao, Taylor, Garcia. Then the rest is formatting. You could put in, we're putting on the Y ticks. We are going to do a range from 35 up to, but not including 55 in increments of 5. You could remove this, see what it looks like, and then if you don't like the way that it's formatted, oh, wrong thing, you could change it. So we see here, when I do this, it goes down here, up, like that's probably fine. We probably don't need to manipulate it anymore. But if you wanted to make it look different, you could say use NumPy to create a range 35 up to, but not including 5 in increments of 5. The X ticks, we have these dates here. We've made them 45 degrees. Anytime you have long information, just make it 45 just to make it a bit more concise. So we create that. And here we go. So what we can see is that Zhao tends to talk slower than our ideal 44. And then we can see how the amount that people talk, or the speed at which our salespeople talk, varies. So you can see the range here going from 35 up to, let's say, 43. You can say this person ranges from down here at 40 up to, let's say, 48. So you can see the variability. And then we look at, can we predict that variability? Is it random? It looks kind of random here. But perhaps as we get towards the end of the month, our salespeople get more tired. Maybe they start to talk slower. Maybe there is a weekly pattern. So depending on the day of the week, they might talk faster or slower. You know, if we're starting to see these cycles in this data where at the beginning of the week, they go down and then they get more energy and talk faster and then they get tired. And then by the end of the week, it slows down again. You're looking for patterns in the data. And we will, as we analyze our data with our predictive analytics, be looking for those patterns so that we can predict what's going to happen in the future. Right now, we're just trying to describe with descriptive analytics what is happening. And so this graph shows the variability in their speaking and how fast they talk, as well as the average where they tend to congregate. And so we've added this benchmark in here as well so that we can help train our salespeople and motivate them to encourage better sales with our employees. All right, so we have done a line graph. And with the line graph, we saw that we had nominal data here, Zhao, Taylor, and Garcia, and then we had time. Okay. All right, stacked column chart. with a stacked column chart. Again, we're looking at time. But what we can do is we can create, say, this column chart here, which compares March, April, and May. So we have discrete measures of time as opposed to continuous measures. So we're looking at March, April, and May. And here what we can look at is we can look at our customer base and what type of relationship we have with them, so that we can see over time, is that relationship changing? So we have people who've been contacted, we have people who we've given a demo to, we have those that we are in negotiations with, those we've given proposals to, those we won. And so what we want to do is we want to look at how many fall into these different categories, and does that change when we compare discrete units of time each month. All right, how do you do a stacked column chart? Well, you're going to need numpy as NP. We're going to need matplotlib.pyplot as PLT, and then we're going to need pandas as PD. So let's import our relevant packages. In this case, what we're going to be doing is we're going to be looking at questions 6, 16, and 26. So questions 6, 16, and 26 is the stage of relationship, and 6 is March, 16 is April, and 26 is May. Notice that this is this data here. In this case, go back. Oop. Let's go to this one. In this case, we have what's our nominal data, these different categories, then we can create that stacked column chart. Okay. So we're going to treat these relationships here as nominal. In a previous video, we treated it as ordinal as you migrate from qualified to, we put it together a demo, and then we put together a proposal for you, and you were moving along the line. So you can choose to treat the data set as ordinal, but if we're doing a stacked column chart, we're really treating it as nominal. We're looking at how many people fall into those different categories, and then does it change? All right, so let's go back in. All right, so let's create a subset of our third data frame. This is the customer relationship management data set, pulling questions 6, 16, and 26. Okay, we'll call it df3_cc. I don't even remember why I use cc. Column chart, stacked, I don't know, who knows, call it whatever you want. All right, so then what we're going to do is we're going to apply to this table. So let's just actually look at, let's just cut it into pieces so we can see it one stage at a time. Okay, so we're going to create that, and let's see what it looks like. df_css.head. So we've created a table with just our 3 variables, and I forgot a 3. So what this shows is here we have our contacted and contacted, contacted. So for each customer salesperson interaction, we have how they're doing in those 3 months. That's the initial data set that we have here. Okay. All right, so then what we're going to do is we're going to apply to this data set, and we're going to do value counts for each of the series. So you can leave all this here as is, and then the only part you're really changing is whatever you're naming that table. When we do that, so I'm just going to remove that so we can see it. CSS. What you see here is that we have counted, so value counts, count the number of people that were contacted in our month of March, count the number of people who were contacted in the month of April, count the number of people who were contacted in the month of May. That's what you see here. Then we repeat that for demo, for lost, for negotiations, proposal, qualified, and so on. So we're doing a value count. We're applying it to each series. We're using pandas to do it. We're applying it to each. Okay, so what it's doing is it's taking each variable and it's saying, what are the different categories? How many people are in each category? That's what it's doing with this new data set. Okay. And then we reset index into the renumbering system. The other thing we want to do is we don't actually need, let's just see, let's run this. Okay. So we're going to give this a label, a column label called index, so that we can call it later. We'll name this stage, okay, so that we can use that. All right, so let's take this, let's get rid of that. All right, we're going to take this table and we're going to transpose it. So we're going to switch what's on the columns and what's on the rows and flip them. Okay, that's this T part. And then when we do that, it's going to mean that the first row becomes this index of contacted, demo, lost, and so on. We don't need that in this table, so we're going to remove that. This -1 removes the first row after we transpose. So we'll flip this so that these become the rows, this becomes the column, but then we don't need to keep this as the first label. So if we do that and we reset the index, we get a new table that looks like this. So notice this contacted, demo, lost is gone from this. However, we have saved it as the name stage. Okay. So now that we have done that, we can then create our plot. So we are doing the name of our table here, SCC, and we have plot.bar. So it's a bar plot using a different method than the previous bar plots. You'll notice this is formatted a little different. And stacked equals true. So when we make it stacked, we put all of this information together in one bar. Now, what we're going to do is we are applying from our SCC table. We can format the X ticks. So the X ticks here, we want them to have words. And if we look at our data set here, they're not words, they're question 6, question 16, question 26. So we want to replace what's in the 0 location with the word March, and what's in the 1 location with April, and the May location with 2. Notice these are locations, not values, because the actual labels right now are Q6, Q16, Q26. So we put that on there. The x-axis is going to be month, that's this. The y-axis label is going to be count, that's this. And then our legend is going to be the stages. So that's why we saved it, so that our colors are going to be based on the stages. And our B box to anchor is going to be centered, but below the table. And then our number of columns here is, we could change this. Right now it's set for 4. Notice that because there are 7 different stages, after 4 it wraps. So you can decide how many columns do you want. If you do 2, of course, it's going to extend your graph down much more. So how many can you reasonably fit in on the screen there? So we do this, and what we can see then is contacted is blue. So the amount contacted declines by May. We're taking care of contacting many people. We can see that we do about the same amount of demos per month. Okay. Our negotiations picks up as we cultivate more relationships. As time passes, we start to do more negotiations. And then the pink are the 1. So when we started in March, we hadn't won any contracts yet. We were new. We had a bunch of people that we thought were relevant to be customers, but we hadn't contacted them yet. So they had qualified. They were brown here. They qualified as potential customers, but we hadn't yet contacted them. So by April, everyone has been contacted. And then as time progresses, we see more and more contracts have been won. That's what we're seeing with our stacked column chart here. So we can do this if we have time, and then we have our categories in terms of the stages. That's the nominal, and we're counting how many people fall into each of those categories over time. So if we go back to our table here, that was nominal time. Our line graph was ratio in time. And the last one we want to look at in this particular video is a bump chart, where we are looking at ordinal over time. To do a bump chart, we are going to need pandas as PD, numpy as NP, matplotlib.pyplot as PLT. So our standard here, manipulate our table and create our graph. You've already imported all of those, but just in case this is the first graph that you're building, we would run these packages. So in this particular example, what we're going to do is we're going to take question 1, which is the name of our salespeople in our customer relationship management system. We're going to take question 13, 23, and 33. So question 13. So here we have question 13 is our customer relationship health. Very good, good, average, or at churn risk. So we can see that this is ordinal. And at churn risk means that there's a risk that they're going to walk away, that we're going to lose them as a customer. So let's look at then very good, good, average, and at churn risk, and how does that relationship change over time? So we're going to create a new table called DF3 bump because we're going to create a bump chart. We're going to make a copy of just 4 columns from the original to create this new table. So we're going to create this subset, and we can see this with that head command. So here you see the salesperson, and then here you see question 13, 23, and 33. So this is March, April, May. So here we have discrete times. When you're doing ordinal and bump charts, it is discrete measurements of time, whereas a line chart was continuous measurements of time. Okay. So here we have March, April, May. So what we want to see is how our salespeople are doing in terms of relationships with customers over time. So we can then do a replace, and we're going to code this data because the customer relationship management system is not coded here. So we're going to call the at churn risk 1, so lowest for the bad, and then average 2, good 3, very good 4. So we're looking for, can those relationships grow? We are looking for a higher number. If the relationship is worsening, it's a lower number. So we're going to replace that so that when we look at our new table here, df3 underscore bump dot head, what we see is that we have replaced those words with numbers. Okay. All right. So then what we want to do is we want to take this, and we are going to take this table here, and we're just going to look at a particular individual. Okay. So we are going to take our df3 underscore bump, and we are going to create a new table from it that is just about salesperson Zhao. That's this df3 underscore bump A. And let's just take a look at that. Let me just remove this. Head. So here, this is just all information about Zhao. So these are all the different customers that Zhao has interacted with. And then what we're going to do is we're going to transpose that table and then remove the Zhao part from it. Okay, so we're going to take bump A, we're going to transpose it so columns becomes rows and rows becomes columns, and then we're going to remove this first row, which is created when we flip it. So tail -1 removes the first row. So you can see when we do that, what we get is question 13, 23, and 3. And we get all of the individuals, so customer 6, 7, 18, 20. This is all related to Zhao. Okay. Now what we're going to do is we are going to look at March, April, May. So we're going to label time as March, April, May. And then to create a bump plot, here we're going to create a bump plot. We are going to do a figure. We are going to plot subplots. So this is requiring us to put a number of things on a particular graph, which is why we're using the subplots from Matplotlib. And for I in bump A, so here we've created a loop, we are going to plot time, and then we are going to use NumPy to create an array that is going to take bump A, and it's going to take I, so index I, and it's going to put a dot. And it's going to make the inside of the dot white. So it's just an empty circle here. And it's going to loop through. So the idea here is we are essentially creating person 6. We are going to look at 2, 4, 4. Okay. So we have 2. Let's just check this. And then what we're going to do, so we'll look at each of these. And we'll loop through here. And then our Y tick marks are going to be at churn risk, average, good, very good. Notice that we don't have a 0 here because we don't want that lower axis. And we'll rotate them to 45 degrees to get them to fit. And then you can see that it has for spine in spine.value, set visible false. What we're doing is removing a lot of the formatting around this to make it easier to see. What you're trying to do with a bump plot is you're trying to see change in that scale. So here's our scale at churn risk, average, good, very good. And so what we can see here is that we have this scenario where we go from very good, stay at very good, and then it drops to at churn risk. So something happened with this particular individual where it dropped. And then we can follow other ones. We can see good, very good, and back to good. We can see average, average, and to good. And then another scenario is stayed at average. So this one's a little busy. There's too much here. That's because they have a lot of different contracts here. But we're trying to see how these relationships move from one level to the next. So if you're doing a bump plot, it's better to have it very simple, just a couple. Here we're looking at our one individual here, just Zhao. But Zhao has a lot of correspondence with a lot of different customers. And so we want to even simplify this even further to just a handful because this is a lot on one graph. It's better just to have, 2 or 3. You can see it move up and down. But if you're going to do that, this is the code that you would do. It creates a loop. The key is to get your table to look like this, where your rows are the discrete periods, and then it'll track a color for each of these columns. Before we leave the concept of data visualization for time, let's look at one last one, which is the dot plot. So the previous ones we looked at were time versus ratio or interval data, and this allowed for continuous measures of time. We looked at the stacked column chart and the bump chart, which allowed for more discrete measurements of time. We looked at March, April, May, for example, and then we looked at changes in ranking, and we looked at changes in categories. The last one we'll look at is time, where we have 3 variables, because those were all 2. In the 3 variable scenario, what we have is we can have a line graph or we can have a dot plot. And in this 3 variable scenario, we have nominal, so we have categories, we have our measurement of time, and we have our ratio or interval data. The difference becomes whether or not time is continuous, so we're back to the line graph, or whether our time is discrete, in which case we're back to the dot plot that we had discussed previously, used for comparisons. So let's take a look at how to do a dot plot. So again, we're doing dot plot using plotly.express as px, and we're importing pandas as pd. In this case, what we're going to do is we're going to look at our salespeople in our customer relationship management database. So Q1 is going to be our salespeople. And then we're going to look at Q7. So Q7 is the percentage of time in a minute that they are listening. And we're going to have a discrete measurement of time, our March, April, May. So what we're going to do is we're going to take Q1. That's how we're going to group it. So we're going to look at the average listening time, because the mean of Q7. We're going to find the average of Q7 by the salesperson. So that's what this first part is here. If I just do this, remove that. Of course, we need to import our packages. And so if we do this and we say show the average sum, what we get is each of the salespeople, and then this here, Q7, is their average listening time per minute. So in how many seconds, or sorry, what percentage, so just go back, Q7. Q7 is the percentage of listening in a minute. Okay, so what percentage are they listening? So we can see, they're listening about a third of the time. The rest of the data the rest of the code that we have there says, let's take March. And what we're going to do is we're basically going to take this table here, and we need to combine Q7 with the information from Q27, which is our other period of time. So we want to compare Q7 and Q27. So we're going to create another variable which represents the time period. So we're going to use numpy. We're going to repeat the word March, and we're going to repeat the word March for the length of this Q7 here. Okay, so we have our average sum table, and we're going to take Q7 in that average sum table, and we're going to repeat March. So essentially what we're going to do is we're going to create the same table here, and it's just going to have a new variable called time, which is going to be that repeated March, March, March. And so you can see that here. So the same table we created, but now it says March, March, March. Now what we're going to do is we're going to repeat this process, and we're going to do May. So we're going to compare March and May, our 2 months here. And we want to put all that on the same table. So what we're going to do is do the exact same thing we just did, but we're going to create one that says May. So we are going to group by, we're going to find the average of question 27, that's the percentage listening time, and we're going to group by Q1. So I'm just going to pull this out so we can see it step by step here, average sum 2. So here we have our table, we have our salespeople, and we have the percentage listening time. And we want to then add a variable to this, which is going to be that the month is May. So if I go and I put the code back here, we're going to repeat using numpy. We're going to repeat May for the length of that table here. So the 7 rows here. And we are going to then create a variable called time, which is just that May repeated, and we're going to add it to this table. That's what this is here. The other thing we're going to do, because we want to merge these two tables together, is that we want to rename the column 27 here to be question 7. So because we want to merge this table and this table, they have to have the same variable names. So this line of code here says, let's take this table and rename the column question 27 to be question 7. So you can see when we run that thing in its entirety, we have added column time. It says May for every single entry, and we've relabeled question 27 to be question 7. The benefit of doing that is we can now use the concat method to take one table and put another table right below it. So when we do that using pandas, that's the PD portion, what we get is the table here that is March, and here's the table that is May. So now we've created a single table which has our nominal salespeople. It has our measurement of time, which is discrete, March and May. And then it has our interval or ratio data here, question 7, percentage listening time. So as we had just said previously, we need to have ratio, nominal, and time in order to do our dot plot. If time was continuous, so it wasn't just March, May, and instead it was multiple dates, then we would have a line graph that we were building. So let's go back in. Now that we have this table, we can then do our plotly express, that's px. We're going to use scatter. We need the name of our table, which I don't know, I call DP underscore question 7 question 27. Just to make it super complicated. Dot plot underscore question 7 question 27. So that's the name of our table. We're going to specify that X is what we've labeled question 7. So remember, this is question 7 and 27 combined, but it's the average listing percentages that are on the horizontal. That's X. Y is going to be what's on the vertical. These are our salespeople. And then the dot plot is showing discrete point in time with the color coded here. So blue is going to be March and red is going to be May. So you can see here it says color equals time, symbol equals time. We have circles and diamonds here. And so if you're going to have different symbols, different colors, they both need to be that discrete measurement of time. We are then going to put little markers. That's what these are. We're just specifying how big they are. The default is smaller. We want to make sure they're big enough that we can see. And then we're going to add an axis. This axis here, the X is going to be average listening percentage. The Y is going to be salesperson, and the legend title is going to be month. So however we're measuring our discrete units of time. And then we're going to show our figure. So what we see here is that in terms of listening percentage, the lowest amount of listening is Taylor in March. And then you can see the lowest amount of listening in May is Taylor in May. So Taylor might have a problem with keeping his or her mouth shut, not listening to the customer enough. And then we can look at others in terms of how much they change over the 2-month period of time. Some see very little change. So Debbie goes here from like 43 to 46. That's what my face is covering. Others have quite a big spread, right? We can see Smith here all the way to here and Zhao from here to here. So big changes in the amount of listening that they are doing. So we can compare the March time period for each salesperson. We can compare the May time period for each salesperson. But within each salesperson, we can also see how it's changing from March to May.